Now, the last time we got together to do science, we talked about the transfer of energy from one mass to another, and we rolled a steel ball into a battery and measured the effects. Everyone remember that?
Yeah.
Well, we're going to do some more talking about the transfer of energy, but this time we're going to do it with the Ultra Slinky. Ultra Slinky. I took two Slinkies and I attached them together by crimping some electric crimp sleeves around it. So it's nice and tight, and now we've got effectively one Slinky. So we're going to talk about how energy is transferred away. Grab one end of that, Montana. I'm going to stretch it this way.
Oh, you're state.
Oh, yeah, that's fine.
Okay, so we're going to talk about two different types of wave forms, and we're going to talk about two different types of basic waves. We're going to talk about mechanical waves, and we're going to talk about electromagnetic waves.
I like mechanics.
They're both waves, but they work in different ways. And so now, if I take the end of this spring
Let it go.
and I move it back and forth like this, we can see the energy traveling from where I'm introducing energy here down to the end of the spring. And it's traveling as a wave. Now, is the spring itself moving to another location?
No. Yeah, no.
Or is the spring staying in the same place?
Same place.
Yeah, it's in the same place. So I'm transferring energy, and I'm using the spring as a medium to transfer that energy. But the spring itself is not going anywhere, right?
No.
Right. So I'm not moving the spring, I'm just transferring the energy. Rico, you want to take over?
Yeah.
Yeah? Everybody transfer some energy. We'll give Rico about a little bit of time doing it. And he's transferring that energy down to Montana.
Oh, it looks so weird.
Okay, now Montana can transfer the energy back to Rico.
No, you do it. Montana, shake it like this.
Like that. And it's traveling as a wave. You can almost like visualize a surfer just riding that wave down here, can't you? Yeah, you can see the waves, right? Okay, next.
Montana, what?
Yeah? Elbot, you want to be next? You want to make some waves?
What's her code?
Okay, shake that back and forth and make some waves.
Mine is dragon.
Okay. Now, we have different parts of a wave. As you can see, the top of the wave, that's a crest. And where it's deep, keep shaking, keep transferring that energy. We got a top of a wave up here. We got the trough of the wave down there. That's a crest and a trough. And where it's hardly moving at all, like right there, that's its rest point. Okay? Okay, who's next, Vash? Come on up.
Who's going to hold this for me? He will not steal it.
Yeah, after Vash. Okay. Go ahead and shake that spring and transfer some energy down it. There you go. Oh, yeah, that's fast. That's fast. Look at that high rate of energy being absorbed.
It's going up and down this way.
Yeah.
And when it's moving up and down, it's energy. It's never ending. It's so high.
Now remember, the spring isn't going anywhere. So we're transferring energy, but we're not transferring matter. Okay. Creed's turn.
Here, give me who's going to give me where's my thing? Yeah, sit down. I think it back.
Okay, everyone sit down, please.
Move it somewhere.
Okay, Creed, your turn.
Creed, move back. Move it up down. Whoa, it's like
Vash.
That's cool. Okay, we'll do it the same time, up and down. Ow!
Okay, let's not take your nails out. We can do a different kind of wave now. Montana, let's stop.
Can we go in a circle?
I don't know. Maybe we should try it though. Okay, now what we were doing before, these are called transverse waves, where it goes back and forth or up and down like that. And that's what happens is when the disturbance of the wave is perpendicular to the direction of the energy. So the energy's flown from me to Montana, and it's moving back and forth like that. That's called a transverse wave. Transverse wave. Can everyone say that? Transverse wave. Now we're going to do a different kind of wave. I'm going to push the spring and pull it back like that. Everyone see the wave?
Guys, just follow it.
Okay, that's a longitudinal wave. This is where the disturbance is happening in the same direction as the direction of the energy. So this is a longitudinal wave.
And it goes back.
And yeah, it echoes back. That's right, like an echo of sound. Like that.
How many can you do? Do it fast. Whoa! Wow. It's like gunshots.
Yeah. You want to send some longitudinal waves back to me, Montana?
Mm-hmm.
Okay, go ahead.
No,
No, those are transverse waves.
Okay, like this.
Those are transverse waves. We're going to do
and take it.
longitudinal waves. Like that.
And you push it forward.
Okay.
How many can you do, Montana? Let's see if I can
Now.
feel it. Yeah. I want to feel it.
If we look in nature, we've all been to the lake, right? I know you guys have. I know you have. We've all been to the lake. Okay, let's keep this quiet so we can talk about waves for just a second. Those up and down waves that come to the shore, those are transverse waves. But another wave that you're experiencing right now is the sound of my voice. Those are longitudinal waves. My voice is compressing the air a bit, and then when it's reaching your ears, it's vibrating your eardrums. Now, all of these waves that we're talking about, the ocean waves and the sound waves, those are all called mechanical waves. There's a medium that they're going through. The waves at the lake, the water, the energy is transferring through the water. In the sound, the energy is transferring through the air. But there's another kind of wave that doesn't need a medium. It doesn't need air, it doesn't need water, it doesn't need ground. If I thump on the mat, I'm creating a very small wave that's going out to you guys. And the medium is this mat. Or if it was a big earthquake, the medium would be the ground that those waves are traveling through. Those are called seismic waves. But those are all mechanical waves. But electromagnetic waves are waves like light. The light is coming at us in light waves. We can't, and it doesn't need air to go through, it doesn't need water to go through. It can go through nothing. Same thing with the microwaves. When you microwave something in your microwave oven, those microwave waves can go just through, they don't have to go through any medium. Those are electromechanical waves. So can everyone say that? We've got mechanical waves and electromagnetic waves. Okay, so we got to answer the following questions. Question number 1. A wave transfers blank from one place to another.
Energy.
Everybody agree on energy? You just have to underline it. You just have to check it. See, you got your choices down there. Don't forget to put your name on your paper. Energy, okay. What kind of waves transfer energy to the ear?
What? Sound waves.
Sound waves, excellent.